So, for many problems involving circular motion, gravity and centripetal acceleration by themselves are not sufficient to solve them. So we have to combine the two. A good example of this is suppose that a planet orbits a star that's a distance of 10 to the 5th meters away. Pretty far away. The planet completes one orbit every 0.5 Earth years, so every 6 months. What is the mass of the star that is orbiting around? You look at this and you think, well, I know how far away it is, I know its period, how in the world am I supposed to get the mass of the star? To do that, we have to combine these two things. So what we've been doing a lot for forces is we've been looking at the sum of all the forces acting on something, and then we've been setting it equal to the net force, which is the mass times acceleration. So if we do that here, so we know that if we're looking at the object that's orbiting the star, that object is going to feel a force of g m1 m2 over r squared, and the net force on that object is, according to Newton's second law, m1a. m1, because I'm going to say that m2 is the mass of the star and m1 is the mass of the planet, and we're interested in the net force on the planet, m1a. So, this is totally fine. But now what we can do is we say, actually, we know the acceleration because it's moving in a circle. Of course, many planets do not move in perfectly circular orbits, but it's a good approximation. So, a is v squared over r, which means we can make that substitution. And then we can say that g, m1, m2 over r squared is equal to m1 v squared divided by r. This is key. Setting forces that cause circular motion equal to this centripetal acceleration multiplied by mass is going to allow you to solve so many problems. So get very comfortable doing this. Another nice thing that happens is, at least with gravity, this mass cancels this mass. And now you don't have to worry about the mass of the planet. The problem didn't give it to us anyways, and we don't need it. So this problem is asking, though, for the mass of the star. We don't know the velocity. So we need to find the velocity. Well, luckily we have our period equation. So t is equal to 2 pi r divided by v. And now what we can do is say, let's solve for v, and we get that v equals 2 pi r over t, and we can substitute this into this equation. So bringing this down, we have gm2 divided by r squared is equal to v squared, so 4 pi squared r squared over t squared, and that's divided by r, so times r. So now, this squared here cancels the r on the bottom, and we can solve for m2, which is the mass of the star. So I'm going to multiply by r squared, so I'm going to have m2 equals, multiplying by r squared, I get 4 pi squared r cubed, and then I want to divide by g. So I have over, I already had a t squared, and now that's going to be multiplied by g. And this is the mass of the star. So if we wanted to then go in and find out what the mass was, we can plug in all of the values that we have. So the radius is 10 to the 15th, you can put that in, put in g, pi, and the period, which is 0.5 Earth years. But the main value in this is recognizing that setting these things equal allows you to do so much. It allows you to solve for things that seemingly you can't even do. Other forces that cause centripetal acceleration include tension in a rope. I swing a rope around my head, the tension causes the rope to continue accelerating. And the same goes for the Coulomb force, which is the electric force between two static charges, which has a very similar form to gravity. And just for laughs, that force is, I'll call it F electric. It's equal to the charge of the first object times the charge of the second object, divided by 4 pi epsilon naught r squared. Yeah. So that is another equation that if this is causing, for example, in an atom, if you have electrons orbiting a nucleus, you can say, okay, well this must be equal to the mass of the orbiting thing times the square of its velocity over r. And then you can solve for whatever you want. So being able to do this is very powerful and very useful. And trying to get an intuition for why this is okay is going to be an important concept that helps you out. So that's how you combine gravity and uniform circular motion. to solve for really cool things, especially in outer space and with planets, and at the very small level with atoms themselves.